the introduction. Captain Vic Lopez, call sign Salsa. I'm an MQ-9 pilot, normally for the Air Force, and I'm still continuing to fly, actually, while I'm out here at the Accelerator. We are a very new organization. Sharing is paused. Bring your shared window to the front. I am unable to resume my share. Why is that? Oh, goodness. Sorry, guys. This is why we had the beautiful setup from before. Okay, now I think we're good. All right, so like I said, MQ-9 pilot by trade. Artificial Intelligence Accelerator is a brand new unit which just stood up and got going really in 2019, but we really started getting our feet under us to start working in January of 2020. Big picture, the way we got started, the president sent out an executive order in January of 19 saying we are falling behind our near peers in AI and for the federal agencies to get after it. In February, Secretary Wilson at the time said that she wanted to help lead that effort. And in March, they decided MIT would be the home of artificial intelligence for the Air Force. In April, they set up a bunch of airmen. We started putting out proposals, call for proposals. We had over 220 proposals called up that we received from MIT and the greater Air Force. We whittled those down to a final 20, and then on October 1st, we had a final 10 picked out after combining the teams from MIT with tactical and program level stakeholders in the Air Force. And by 1 January, money was in hand at MIT, and we started working. Also, as mentioned, we are a three collaboration partnership between the Department of the Air Force, including the Space Force, MIT main campus, as well as MIT Lincoln Lab. And so we are a completely unclassified research branch working on fundamental research along with a couple other things. So that's kind of a really quick background on where we are. And I'm going to give you a quick overview of the AIA overall, and then I'll go into a little bit more about how you can learn more about artificial intelligence, how it might help your program, and how to continue your own educational journey as I have about this rather old, but in some ways new technology and how we can apply it to Air Force problem sets. So we'll start with our organization, go through all of our lines of effort. We had a cyber slide, but we're going to actually hide it for now. We are still working on our cyber engagement, so we'll leave that as a teaser for what's to come in the future. Overall, our mission here is to advance, educate, and deliver artificial intelligence capabilities and make it real for airmen. AI has been a buzzword for a while, but it really gets down to how can it help us. A lot of the talks today have been about how do we remove the rocks of rucksacks of our airmen? How do we give them time back? It was a really interesting presentation this morning from the gentleman from Lockheed, the airmen who talked about they always go 40-hour work weeks are kind of the standard, and you don't want to make overtime. Get in the Air Force where we say that we value our people. We don't mind overtime. There is no such thing as overtime, right? If the crew chief has to work 60 hours a week, he works 60 or 50 hours a week because that's what's required of him. When the reality is we should be trying to figure out a way to give them time back. And maybe artificial intelligence is the conduit to do so. Overall, our current landscape, so we have, we're a very small unit. So we have only 11 active duty guys out here full-time, 4 reservists. And then we started bringing on ROTC and USAPA cadets from the local area who wanted to help out and help us kind of get things over the hump, if you will, doing maybe some labeling, some research of their own, and figuring out ways where they can plug in. Where our real strength lies is in that partnership. So overall, between MIT main campus and in Cambridge, as well as Lincoln Lab, which is a federally funded research development center connected to Hanscom, but part of the MIT system, there's 60 researchers out there and 90 from main campus. We try and work with as many people as we can. Obviously, we're not the only ones in the AI game in the entire DoD. As you'll find later on in the presentation, data is going to be king throughout the next wave of development for artificial intelligence and DoD capabilities. And so in order to do that well, we need to ensure that we are not stovepiped and that we work well with all of our other partners, including the people who are already doing great work in AI, such as the JAIC, DIU, AppWorks, Kessel Run, et cetera, et cetera. So understanding where we fit in that ecosystem has been really important. And it's been a really great year, just these last 12 months, almost 12 months now, getting to really understand these other organizations. So what do we do on a day-to-day basis? We have 10 projects, like I said, that we funded. The first is called Air Guardian. These are all funded for 3 years at a total cost of $15 million per year. and we separated that between the 3 projects. So Air Guardian was the first one that we had, and we're still working on this, obviously, all very research-based. But we want to see, is there a way to augment the pilot in a way which can help them in the same way that some of the ground collision avoidance systems in the F-16 has helped save pilot lives? And can we take into account feedback from the aircraft, feedback from the person, and other data? So one of the things that we're very happy about is we were able to get terabytes of flight data recorder data, so all of that black box information onto the CDO's vault. I think we mentioned the CDO, the Chief Data Officer, has of the Air Force, has a great web-based portal where we can put all of our data. And now we're in the process of trying to figure out how to make that a benchmark data set so that we can do things like maybe figure out how to optimize the flight pattern, or even take some of the FDR data or some of the voice box data and figure out how to create a natural language processing model so that we can do some analysis. And maybe whenever I go in to check in my close air support scenario, I can ask R2 in the back, if you will, the AI agent who has been listening to my conversations and all the radio chatter, how much time Viper has left on station, or how many weapons he has left, instead of trying to mark that down on my sheet in the cockpit furiously as people are talking on the radio. Fast AI is all about data lakes. So we're trying to figure out how do we take lots of information and figure out new ways to bring that to the capability of actually being able to perform analysis on it. And so another thing that's really important to remember with data is the Air Force has a lot of data, not as much as the private sector. We like to think we do, but we have a lot of unlabeled data or unusable data for machine learning. And so this is trying to figure out, well, is there new ways to organize it, novel ways that take some of the grunt work out of cleaning and organizing the information so that we can actually process it through machine learning applications. This is my project, transferring multi-robot learning for virtual and augmented reality. It gets very technical in the title. I just call it Small UAS or Quadcopter Hatter Humanitarian Aid Disaster Response. What we're trying to do here is train swarms of aircraft, small maneuverable quadcopters, to actually go through very new and complex environments that are difficult and go building to building, room to room, hallway through hallway, and perform a complicated search and rescue mission for humanitarian aid and disaster response scenario. The key to this, however, is not going to actually be the swarm technology or the ability to fly autonomously through a building. But more so, how do we transfer learning or information from whenever we're training a deep neural network from simulation to the real world? So if you think Tesla is probably the biggest example. Tesla has millions, or I think it might not be millions, maybe hundreds of thousands of cars who have traveled, I think at least millions of miles by now. They've collected all that real world data and they begin training on it, which is great because they can get very snowy climates up north, very sunny climates and desert climates in the south. And as they collect all of that data, just in the United States, they're able to train models to better drive their autonomous portion of their vehicle. And they need real information to do that. The trick is in the DoD, we don't always get to fly or train where we are going to fight in the future. And so this real, the real golden part of this transfer mobile learning is, can I take a simulation and get the robot to learn as well in simulation and then transfer it immediately to the real world? And if so, we can train just like we do as humans in simulation our robots, which would be a really big breakthrough. Multimodal vision for SAR. There's a bunch of different work streams in this one. The one I know the best is trying to take a SAR image and train it with what the real world EO image looks like. So that the DTV, the color image, if you will. And can I take that radar, train it with enough EO images, and then get it to basically take any new SAR image and immediately colorize it and make it so that it's easily interpretable by an analyst. Sorry, I was having a little trouble getting that word out. By an analyst. SAR images are notoriously just kind of hard to interpret, but if we're able to train a model to be able to translate it into a DTV image, it opens up lots of possibilities and lightens the workload on the people, because way more people are able to understand and interpret a DTV or color image than a SAR image. So we're still working on this one, but so far we've actually had some really good progress. Magnetic navigation, this one's really cool. We actually just put out a challenge for this one, and ASU responded. And so we are trying to figure out, a researcher at AFRL found out that stay with me for a little bit if I lose you guys, but the gradient or the change of the magnetic field over the Earth is actually unique at every point. And so the thought is, can we use the Earth's magnetic field as a geo-reference to geolocate our aircraft in the event of a GPS denial? And if so, can we use that then to navigate and move our aircraft and understand where we are in the world? And so we are currently working to clean some of the data as kind of our step right now of the sensors on the aircraft to interpret that magnetic field of the Earth, calculate the gradient or the change of that magnetic field, and then be able to geolocate us with all of the interference from the aircraft and the metal around that aircraft. One way it works always is by putting a big tail and the sensor basically on a string way behind the aircraft, and that works really well. But obviously probably not like the tactically best solution to have some sensor hanging on the back of your tail. So really exciting work here. And again, huge implications for the tactical side of our operations. Alexa for the Air Force is what we name this. Don't tell Amazon, but it's kind of our short name for it. What we're trying to do here is trying to figure out a way to create a natural language processor, something that can understand our speech, and also be able to give us recommendations in context that makes sense. And I know it's a little bit of a lot, but if you imagine it's the best Control-Shift-F on your PDFs that you've ever seen for the Air Force. So instead of me opening up all the relevant pubs for whatever ADLS training I have and Control-Shift-Fing through all of them to find the relevant sentence that I need to answer the question, I could just ask Alexa, hey, what does crew rest mean for pilots? And it would pull up through all the different publications the relevant information that makes sense. And that's actually a quite difficult problem if you imagine your own Google or Siri or Alexa or whatever you have. It usually can do really good on the first question, maybe a follow-up, but it's going to give you very specific and very singular answer, and it might not be able to understand that there's other things that kind of play into that context. And so that's really the crux of that research. In addition, we're also trying to look for more information on how we might be able to better language understanding through that process as well, and create an individualized language learning experience for airmen that fluctuates the training a little bit based on how that user is doing and understanding the context of the language around it, which is another really exciting part for both the civilian sector and the DoD. I'm actually going to, we got a couple more, sorry. AI Enhanced Spectral Awareness is a really cool project as well. If you imagine, I'm wearing a pair of Bose noise canceling headphones, so any noise, I don't think the dog's barked yet, but if he does, hopefully my noise canceling headphones will figure out that sound and will actually feed me a directly opposite sound to block out his signal or his noise, if you will. So AI Enhanced Spectral Awareness is basically doing the same thing, using machine learning to try and identify an anomalous signal and actually cancel it out. And so using all of that information, we're trying to figure out a way to make our C2 systems more robust. And obviously this has huge implications for multiple different reasons. And again, this is very much a dual use technology. If we can figure out a way to frequency share frequencies in the US, we might be able to put multiple people on the same frequency, but still be able to communicate, which would be really exciting because we increase our bandwidth availability. And then from a warfighter perspective, if you have the ability to pick out your signal from the jamming noise, obviously that gives us much more robust capabilities downrange. And I will pass this off. We actually have Captain McAlpin Gouge on the line, so I'm going to let him present his project shortly.
Thanks also. Hey everyone, I'm Kyle McAlpin, go by Gouge. I'm a C-17 pilot, former T-6 instructor, flying out of Joint Base McGuire right now, but also at MIT with Salsa. So just give you a quick rundown of my project. Basically, we're trying to understand the human better. And there's a bunch of cool things you could do when you've done that, but one of the goals we're applying that to is pilot training first. And what we want to do is identify when the human is cognitively stressed. So when you're task saturated, when you're channelized, there's some kind of pilot terms, so sorry if I'm losing some people, but real simple things like fatigue, task saturation. We want to identify all those things using unobtrusive biometrics. So something as simple maybe as a Fitbit, if possible. and use that to help people train better. So we want to find that flow channel that everyone is so familiar with in sports, and use that to train people in flying training and eventually in any cognitively demanding training regime, and help them train better by understanding when they're in the flow channel and maybe dialing up the difficulty in real time, or we say sometimes like titrating the difficulty in real time to either make it harder or easier to optimize, to maximize their training as they're training. That's all I got. If you want to move on to the next one.
Oh, sorry, my fancy mouse here took off on me. Okay, thanks, Gouch. And I know we had some talk in the chat about some virtual reality simulations as well. And all of that very much goes into line with Gouch's project. So we're happy to continue to interface with you guys on that. Earth Intelligence Engine, this is another one of those projects that has multiple work streams. I'm going to talk about the part that I understand the best. So data, like we said, is a very difficult thing to not only wrangle, but then clean and make it possible to actually apply a model to it that will give us good results in the end. And for weather data, that is one of the very rare abundant cases where we have lots of labeled, great geolocated data of what the weather did in the past and what it did after, every 5, 10, 15-minute increment, which we collected satellite and PyReps and radar data to understand how weather systems moved. And so it's a right candidate for machine learning, where we can take what happened in the past, teach the computer what happened in the future, and then get it to build a model to allow us to better predict the information. And so one of the things that we're working now is between CyberWorks, Lincoln Lab, MIT main campus, and ourselves, is can we apply that, we'll call it global synthetic weather radar model to the MQ-9 fleet, so they can have an individualized synthetic weather radar, that is a fake weather radar. So instead of installing a radar on their plane, the computer actually takes whatever information is publicly available and creates an individualized weather model for each aircraft across their mission domain. And so that's the first one we're testing it with. Obviously, every aircraft, every unit, every base is going to want that eventually, right? Knowing when you can take off, when you can't, when your winds are going to be out of limits, and being able to kind of live life a little bit closer to the edge based off of that information. But lots of really great work being done on this project. Excuse me. The Puckboard project, or AI-assisted optimization of pilot training schedules. Some of you may have heard of Puckboard. It's been released, I think, to 5 or 6 bases now and a few different units. We're starting to collect data. So this is actually I believe, a Kessel Run development of how do I make software out of the training schedules that pilots usually in some squadron have to make using pucks on a whiteboard. It's very manual, it's very time consuming, and there's usually a lot of turnover. At least every 6 months to a year, a new pilot with barely any experience jumps in the seat and has to figure out how to manage an entire squadron of deployments, aircraft maintenance cancels, et cetera, et cetera. We've talked a lot about that from a logistics perspective. This is a little bit more from the pilot perspective. And so the software is one piece of it, but the other piece really is, can we also build a model which will help the pilot better predict or better schedule things in the future based off of whatever happened in the past. So things that we're excited to look at is, this is really an optimization and a regression problem, if you will, from a data science perspective, is how do we either optimize the pilot's time, how do we spread out instructors, spread out evaluators, ensure that people aren't going TDY too much. There's probably a balance between how many people we can have on the aircraft versus, what are their qualifications? Is the aircraft maybe partially mission capable and can run some type of mission, but not other types of missions? And is there a mission that then fits that? And how do I move all of those things in a very real time? And then obviously things come up. There are maintenance delays, maintenance cancels, aircraft break, pilots break things. Pilots get sick, crew members get sick, babies are born, TDYs pop up. So all of these extra uncertainties, whenever those happens, the computer is able to understand that and still optimize for things much better than a human can. And so this is a right problem for artificial intelligence to try and step in and make the pilot's life easier, and also make life better for everybody else who's trying to manage their own time and give some of that back to the airmen. So it's kind of a quick overview of the 10 projects we have. In addition to that, it's a really, we're doing some consulting on the side. We're still trying to figure that out. Again, there's not too many of us. So as Major Bleha talked about, some of the consulting projects we have are with USAFE, as well as Naval Air Warfare Combat Division. We're looking at how to automate airfield surveys. So the airfield survey process is very manual, where you send a team of a few people out to an airfield. You drill into dirt, make sure that things can land, how many hotels, what kind of fuel, how many runways, taxiways, do they have all the logistics in place, security posture. Lots of things go into understanding what type of bases could potentially host us in the event we need to move left or right, hurricanes, natural disasters, et cetera, et cetera. Most of that data that I just mentioned lives on the internet somewhere. And the hardest part of that problem is getting all of that data in one single repository, so a poor airman doesn't have to Google a million places. But it also probably doesn't make sense to send them places to do that. And so there's a data problem. So most of our effort there initially is going to be focused on how do we get all this data into one place? How do we get it organized? How do we get it labeled? How do we make sure that we can trust it? And then once we have that, now can we build an algorithm? That's actually the much easier part to optimize the warfighter that needs to move forward, right? Maybe it's a full-on sprint. We need to get everybody out because the hurricane is coming, and we don't want our aircraft to be damaged. Where are they going to park, and do they have gas to get back whenever they park there? Is there apron space, taxiway space? What's the security like? Can the airmen get hotels nearby? All of those questions obviously are important, but most of those can be answered on the internet. Same thing with drilling the holes through the runway. Obviously, if we can do that, that's awesome, just to make sure that everything underneath it is good from a civil engineering perspective. But likely, if it's a civilian airport and hundreds of 787s have landed there over the last few days, probably safe to land a C-17 there without too much risk, additional risk being added. And so transition of that technology is really important. And all of our projects have a tactical end stakeholder, as well as the program manager stakeholder or program office stakeholder that will ensure that we can transition technology, someone's willing to pay for it, and then obviously someone is willing to use it. And interfacing with both of those is really important for us as we move through this. So it's kind of a little bit of our stakeholders, how we innovate, and trying to figure out how to really understand AI from a research perspective and bridge the gap between what the PhDs and some brilliant scientists and engineers at MIT want to do, and then the really difficult challenges that airmen have. And if we could just get them to talk, is really where we hope to shine. I'm going to tease this a little bit. Another part of our charter is AI education. Again, we've only been around about 12 months of like good earnest work, all during a pandemic mostly, except for the first 2.5 months. But we're working really hard to push out to the rest of the force how to get AI education centered and something that senior leaders as well as airmen on the line can do. What we found is anyone from enlisted all the way up to the higher grades with master's degrees and PhDs are really interested in this stuff and really want to learn more. So it's really on us as leaders to figure out a way to provide them the tools and education to be able to apply that to their own units. And I think some of the maker spaces that we've seen briefed from the 3D printing innovations at Travis Air Force Base to some of the continuous process improvement are really testaments to how much airmen want to help and want to make things better. We just have to train them to do so. And the old training won't quite do it. So we're going to have later on a quick, hopefully by January, we'll be able to present something on AI education for the force, so look to that. We have a website, aia.mit.edu. I'll put it in the chat, or if you want to learn more or reach out to us, you can. aia@mit.edu is the email address that will go to everybody, and so if you have questions, you can ping the team that way. I'm going to pause there, and then I'm going to go actually through a little bit more AI education and where you can go to learn about AI, the different facets of machine learning, and go as thin, maybe a mile wide and an inch deep, or if you want to go a mile deep and an inch wide, you can do that as well. But I'll pause for any questions about our projects.
Yeah, this is Daryl Venture. I do have a question about, do you have any work, are you doing any work on cognitive electronic warfare?
So you came broken there at the end there. Cognitive what now?
Cognitive EW, electronic warfare.
I'm not familiar with anything we're doing with cognitive electronic warfare. That's probably more saying about what I don't know, though, more so than whether or not we are. If you send an email there, though, I can try or if you want to send me an email, I'll put my personal email from MIT in the chat. For more specific questions, I can shoot you over to the airman in charge of electronic warfare, and she is brilliant about that, and that's all her projects. So I can hopefully get a better answer for you than I don't know. I'm sorry.
Okay, thank you. That's great. Now, I also have a second thing there. And I don't want to get into programs that the government uses, but I was a project manager on one of the programs that the government uses for scheduling and for operational tracking of things in a unit, flying unit. And we had come to the conclusion that we had everything we needed in the data. We had all the data we needed for automatic scheduling. We just didn't have the requirement by the MAGCOMs to build it. And it seems like the people who are working on AI assisted optimization of pilot training, the guys who are doing auto scheduling, could very much delve into this database that I used to work with or something like it and provide those algorithms and have a very good solution very quickly. I'd like to be able to talk to them, but I don't know what the protocol is on that.
Gouge, did you pop up to say something?
Nope, just listening. But yeah, I think more data is always super valuable and can never hurt. So that seems like a fantastic connection.
For sure, yeah. So if you want to, that's AIA at MIT.edu. If you want to just say, hey, I heard about what you guys are working on for the AI optimized training schedules. Puckboard is the short name. That's the name of the application that Kessel Run built. This is the database I worked with where you can get X, Y, and Z. Highly, just wanted to let you guys know, or if you have other questions about the database. And I'm sure we'll get that over to Captain Carter, is the lead for that project, as well as Kessel Run. They're still looking at ways to optimize that, to grab more data and more information to be able to better train the models and spit out something that's useful for the pilots. So I know we've been looking a lot at obviously at ARMS and PEX and a couple of the other databases out there that can give us some of that information and ways to streamline the data collection, because I know at least for the MQ9, I still log all of my information on a tar sheet with little dots. It's very manual, and we have to go to something more electronic and more fast so that we know exactly what happened after that flight to be able to better plan for the future.
Exactly. Thank you.
Hey, Salsa, one of the questions that came up, and I know some of the people in the audience are going to end up on projects down the road some point in time. Can you talk to data standardization and the importance of it, and then also what standards are being used to help y'all when you actually try to conglomerate all this data together for an AI?
Yeah, for sure. Lots to talk about in the data conversation. Gouge, correct me if I'm wrong, did Lincoln, didn't we have somewhere, I know we posted something somewhere in our channels about a standardization sheet from Lincoln. Is that accurate somewhere?
Yeah, we got some real basic sort of like quick guide and a 1 or 2 page guide to basic data standardization. Yep. Okay.
I don't remember where that is. While I continue answering the question, if you maybe shoot that over to me, and then I'll see if I can put it up somewhere for everybody.
Let's see if we can find it real quick.
Thanks, man. To continue though, some of it's very basic, all the way to some of the more complex information stuff. So for some of the basic things, ensuring that whenever you're procuring a thing, a widget, a gadget, something that's going to collect data. One, if you can, see if it can collect the data in real time with minimal extra work from the person. As we've seen in maintenance, right? After you've been crawling inside an F-16 engine on the flight line in Arizona in the summer, you probably aren't going to want to sit back and write a detailed report about what you did and how long it took you, right? I think the information this morning was they saw their crew chiefs were only working 40 minutes, right? That's what the data said, and that's not accurate. So figuring out a way to do that, ensuring too that we always have access to the data as a DoD and as an Air Force, so that we can analyze it later, and that it's quality data, that it's accurate, and it's timely, that it's all visible, and the Air Force Vault, I think, does a really great job. The Vault platform itself, the acronym, all stands for all of those things to ensure that it's readily accessible. The other thing is making it as easy to read as possible. So if you have to open up a special program to read your data, it's probably not going to be super helpful. Ideally, what data scientists love is something as simple as a tab-separated file, CSV, that gives you this is what, this was the date and time of what happened, maybe an anonymized code for maybe the person that did it, what they did, and any other outcomes that you saw from that information. And something as simple as just making it into a tab-separated file does wonders for us, because now we can actually put that through an algorithm to give us something, right? And there's lots of different things, this could go down for. Lastly, it's going to be ensuring that your data is organized into batches for time and georeferencing, right? If we have the time and the date, it's a little bit easier to connect disparate data sets, but also understanding that this data set, let's take the airfield survey one, for example, or the FOD detection problem. I had a FOD event in Phoenix in the summer during a windstorm. Is really important information to know. But if the likelihood of a FOD event is what I'm trying to predict, and I use the model from Phoenix, Arizona during a windstorm in the summer, it's going to be very, very different than a storm in the summer in Massachusetts or in New England or in Jersey. And the amount of stuff that's going to happen is going to be different per geolocated area. And so understanding that a batch of data to create an algorithm may work in one location, but it may not translate well to another location is really important. And at the heart, machine learning, for all of its fanciness, is really just math, right? As everyone knows, when you build a mathematical model, how one model will show growth is not necessarily how the rest of the models will show growth, right? None of us can sit back and take the Tesla model for how their stocks, increased this year to an astronomical high and try and apply that to Ford or GM and expect the same results. They're just different things, right? So understanding that at its core is really important. To go more through that, I think that's a great segue, if there's no other questions, through some more AI education stuff. So I'm going to bring up a couple websites here. Major Bleha, did that answer your question before I continue on with kind of where to learn more?
Yeah, absolutely. Data seems to be a reoccurring theme through the event here, so it's pretty interesting. And I know some of us are going to get pulled into different projects, and it's better to do it right on the front end versus try to fix it on the back.
Yes, please. Yeah, because it's going to create lots of heartache for guys like us whenever we're trying to understand and read data. Gouge has great stories from Pilot Training Next about some of the data and trying to interpret a model on, okay, this was a loop, but all we have are velocity vectors from the sim. So how do I translate a velocity vector into the sim into knowing that they did a loop? And then how do I judge the goodness of the student's loop from a velocity vector? All open questions that are really difficult. But good if you have really awesome labeled data. So then what I want to take you guys to then is a new thing that just launched, if you haven't heard, digitalu.af.mil. So this is Digital University, and a lot of times, like I said before, we're trying to figure out how to educate airmen on this stuff, but also make it so that they can actually apply it in their day-to-day jobs. So Digital U is the response to that. So there's over 12,000 courses here in lots of different things. Currently, it works with, I think they're eventually going to go to like Udacity and some nano degrees as well. For now, the contract is open with Udemy. And so if you go to digitalu.udemy.com, you can actually register with your af.mil. This is for everybody. So I'm going to put it in the chat. digitalu.udemy.com. I think I spelled that right. And so this is my learning path, so you can see some of the stuff that I'm taking. And there's lots of stuff on here, but if you search specifically for artificial intelligence or executive briefings on AI, I'll put that in the chat as well. You'll actually be able to go through, these are really short courses. I usually listen on 2x, right? So it works on your phone, on your work computer, so it's not blocked on the nipper. It works obviously at home on your home computer as well, but you can download the Udemy app and log in with your af.mil after you've registered with your military account, your military email address. And these are all free courses now available to airmen. So you can take an executive briefing on AI. This one is really solid. Again, only 2 hours. But when you go through it, it'll walk you through what is computer vision. So how do computers see things and where could we use that? Lots of case studies as well with real results on what commercial organizations have been using this and can they, how might we apply that, right? Maybe we apply it to the maintenance world, maybe we apply it to something else. I know Major Bleha talked about, counting his steps on his cell phone. All of that is actually part of that on computer vision as well. Just getting a computer to understand where people are walking, where are those hotspots, how can we optimize our office spaces, especially the manual ones, to minimize the time that we're walking between things. Deep learning, so if you really want to get to neural networks and how those work. Reinforcement learning, which is all about how does the computer learn on its own. Natural language processing, which we talked about a little bit, right? How do I get something to understand a sentiment analysis? Maybe you're looking at comment cards in the Air Force to know, is my organization doing well? Is it doing bad? And you don't have time to read everybody's comments, but can you apply an NLP model and say everyone's really angry at insert name of service because we're always late or whatever. Maybe that's a good way to start working through that. Robotic process automation as well, and next steps. And this is only kind of start of it. You can go as again, if you want to go a mile wide or an inch deep, or the reverse. He has executive briefings on, that go more in depth into each one, 35 minutes, 38 minutes, etc. Or if you want to go all the way to build an AI and use the code and use all the free tools that are on the internet available now, all of that information is there as well. So I'll pause for any questions on Udemy and how you might use that to really start digging into more how we could use artificial intelligence in the workplace. Sorry for showing my emails there. And
yeah, the slides will be available. I have a copy of them, and we're also recording the briefing, Abby, so we'll be able to get that out to you.
Very cool. And then last but not least, I think I'm still sharing my screen. If you guys can see the good architecture checklist, yeah?
Yes.
Sweet. So this is what Lincoln kind of came back to us with as people were asking. So if you want to screenshot this, feel free. Are we looking for data in tabular form? Do we have a time, a measurement, a person? Can it easily be de-identified, right? So ideally, we don't want social security numbers on data. It just makes it easier for us to then be able to process that. Has it been exported and shared with another entity? And then was it any good? So if you shared it with somebody else who's outside your organization and they can understand your data, that is your final check. If you share it with somebody else and they have no idea what the data means, or your columns are mislabeled, all of that is not going to be helpful. If you go through some of the executive briefings, he talks about some really funny stories about a university who I think that the computer didn't say that some of their students were from a certain country. They didn't have a certain country listed. So they said they were all from like New Zealand or like Antarctica or something. I don't know, something like, very small. And so later on, whenever they did the analysis, they were so excited to see that however many of their students were from this, really abstract country, when the reality was they weren't there. The data was skewed. They had put that there as a placeholder, right? But as you can see, it's very quick to understand how that data can be go against you whenever you don't understand how it was collected. And then one book I'll push as well, Weapons of Math Destruction, is really good to understand how data can bite you. So I'm not affiliated with this book at all. I don't make any money if you go. But for this book, she talks a little bit about how we could potentially use math in a way that can end up hurting our airmen or hurting people, and making it so that you have garbage in and garbage out under the guise of we're using some type of scientific process of data to make good decisions, and the dangers of doing that too frequently. So another really good book. So some education there, some places for you to go and things to read. Hopefully that will help as people move through their journeys in data and